questions for our test review. So remember, the first thing we want to do when we are solving for the variable in the radical equations is to isolate the radical. So we're going to add 5 to either side. So that gives us the third root of 4x plus 1 is equal to 5. Then we want to go in and cube both sides to undo the radical. Inverse operations. So the left side becomes 4x plus 1, and the right side is 125. We subtract from both sides. 4x is equal to 124. X is equal to 31. Then remember, we need to go over to the other side, and we want to check our work. So we want the third root of 4 times 31 plus 1, and we want to subtract 5 and see if that's equal to 0. Well, that's the third root of 124 plus 1, third root of 125, which minus 5 does equal 0, because third root of 125 is 5. So this is our solution. We're going to move to the second problem, B. For B, we're going to start off, we want to isolate our variable, so we're going to divide both sides by 3. That gives us that the square root of x minus 11 is 6. We're going to come in to undo square root. We square both sides. So x minus 11 is equal to 36. So x is 47. We're going to check our work. So 3 times the square root of 47 minus 11. 3.
Teachers, at this time, if you are able, go ahead and leave. We don't need the supervision. The campus is pretty much clear, and the roads are iffy. So if the teachers, if you want to go, teachers and faculty members, if you want to go ahead and leave, you're welcome to do so at this time. Thank you.
Okay, on the third one, we're going to cube both sides. So that gives us 3x on the left, 2x plus 9 on the right. So x is equal to 9. So that's our solution. Let's move on to D. We want to square both sides to get rid of the radical. Square both sides to get rid of the radical. When we square over on the left, oh, whoops, we got rid of the square root, sorry. 8x plus 6. So on the left side, we have x squared plus 4x plus 4. We're going to need to subtract 3x and 6. So x plus 2, x minus 1 equals to 0. That tells us our two possible solutions are -2 and +1. But we have to go back and substitute back in order to see if our solutions work. We're going to change colors just because this is getting kind of crammed in. So you put it back in the original problem. So when you use -2, -2 plus 2 is 0. When you substitute it into the other side, square root of 3 times -2 plus 6, that is square root of 0. So both sides work. That is correct. When we substitute in for 1, we're going to go 1 plus 2. We're going to see if that's equal to 3 times 1 plus 6. All under the square root. Is it true that 3 is equal to square root of 9? 3 equals 3. So in this case, both of our solutions checked, which is unusual. It doesn't always happen that way. All right, let's go to E. We're going to square both sides. So 10x subtract 25 equals to x squared. Subtract over, add over. 0 is equal to x squared minus 10x plus 25. And we factor this. This is x minus 5 x minus 5. So our only solution in this problem is 5. We're going to substitute back in to see, does it check? Remember to put it back into the original, not where you solved. All right, so that's square root of 50 minus 25, and that's 5. So that does work. Both sides are equal to 5. All right, let's go to F. Okay, so first thing you want to undo is any adding or subtracting. So we're going to subtract 2 first. Then we're going to undo the fact that they are multiplying by 1/2, multiplied by the reciprocal to cancel that out. Now we have third root of 5x plus 1. On the other side we have 4. We're going to cube both sides. Cube, cube. And when we do that, left side is 5x plus 1. Right side is 64. So that tells us that x is 63/5. Remember we talked about in class, you want to leave it as an improper fraction for checking purposes. So when you substitute back in, I don't know where my equation went. When you substitute back in to the original, oh goodness, something happened up here. All right, we're going to put it back up here. So we have 1/2, and then we have third root of 5. And then 63/5 plus 1 plus 2 equals to 4. 1/2 of those are going to drop out. Third root of 63 plus 1. And then add 2 should be equal to 4. Half of the third root of 64. Half of 4 is 2. It is true that 2 plus 2 equals 4, so our solution is the 63/5. All right, let's move on over. Let's see what's happening. Oh, I think we scrolled over somehow. Let me see if I can fix that over here. Yeah, that's what happened. Okay, there we go. All right, so in G, we're going to go in. Now, this one is a little different. We need to cube both sides, but remember when you're cubing both sides, you have to cube the 2 as well as the radical. So we're going to have 2 to the third times 3x, and on the other side, we're going to have 2x plus 11. So 2 to the third is 8. 8 times 3, we have 24x. Subtract, subtract. 22x is equal to 11. So x is 11 over 22, which is 1/2. Now, with this one, when you check it, it doesn't look like it's the same value, but it actually is if you check it with your calculator. 2 times the third root of 3 times 1/2 is 1.5. That does equal the cube root of 2 times 1/2 plus 11. That is equal to the cube root of 12. Numerically, they do work out to be the same thing. So this is correct. All right, on H, we need to remember when we have a fractional exponent that you need to raise both sides to the reciprocal power, not multiply by that number. So 3/4 and 4/3 are going to cancel. Left side is 3x plus 1. On the right side, you are doing 8 and you are raising it to the 4/3. So you're using your calculator to do so. When you do that, you get 16. 3x is 15, so x is 5. When you substitute it back in, it does check. You're wanting 3 times 5 plus 1 to the 3/4. Well, that's 16 to the 3/4, and that is equal to 8. So that does work. All right, on the next one, this is being raised to the 1/2 power. I apologize for the fact that I kind of wrote over that. So to undo the 1/2, we're going to use the reciprocal power, which is 2. So we have 4x plus 5. On the right side, we have x squared. We're going to move everything to one side because remember, when it is a quadratic, it needs to be equal to 0. We want to factor. When we factor, we're going to have x minus 5, x plus 1. So our two potential solutions are 5 and negative 1. We want to see if we can check that. When we check it with the 5, we're going to get 25. Square root of 25 is 5. That's good. So this is a solution. On the other side, though, when you use negative 1, you're going to have a 1. And 1 to the 1/2 is not equal to negative 1. So this solution is extraneous. You would not report it. You would only report the x equals to 5. All right, let's move